Let's explore performance optimization techniques. In this module, we will cover strategies for optimizing big data processing performance and resource utilization. Here are some of the key strategies for optimizing performance. First, focus on efficient data storage and retrieval. Second, utilize parallel and distributed processing. Third, implement adaptive resource allocation. These strategies offer several benefits, including reduced latency and faster outputs, maximized hardware utilization, and improved scalability and fault tolerance. Let's consider an example of parallel processing using Python. The code starts by importing the pool class from the multiprocessing module. A function called square is defined, which takes a number x as input and returns its square. The code then creates a pool object with a specified number of processes, in this case 4. The map method of the pool object is used to apply the square function to each element in the list. Finally, the results are printed, demonstrating how the input numbers have been processed in parallel to compute their squares. Let's explore data storage optimization techniques. First, use columnar formats such as Parquet and ORC. Second, apply data partitioning and bucketing. Third, utilize compression techniques to reduce storage size. The impact of these techniques include faster read and write access, reduced input-output bottlenecks, and cost-efficient storage utilization. Here is an example of adaptive resource allocation. A function allocate resources is defined, which takes a list of tasks as input. For each task, it checks the task's priority. If the priority is greater than 5, it allocates high resources. Otherwise, it allocates normal resources. The function returns a dictionary containing the resource allocation for each task, showcasing adaptive resource allocation based on task priority. Let's discuss the benefits and challenges of parallel processing. The benefits include improved throughput, reduced execution time, and better hardware utilization. However, there are challenges like synchronization overhead, data consistency management, and load balancing complexity. Let's consider an example of memory management optimization. The code begins by importing the garbage collection module. A function called processLargeDataSet is defined, which takes a large dataset as input. For each batch, it computes a result and yields it. It also forces garbage collection, which enhances memory efficiency. The function then processes large data in a memory-efficient manner. In summary, remember to optimize data storage and retrieval, leverage parallel and distributed processing, and use adaptive resource allocation. Some key takeaways are to balance performance with resource utilization, monitor and profile regularly, and implement incremental improvements. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.